So for exponentials, let me quickly run through 4 examples. So here's how we do this. Let's say you have this equation here. Now, look, the number in the back, whether it's positive or negative, whatever it is, this positive 3, I go to positive 1, 2, 3 here, and I make a dotted line, and it's always going to be horizontal. Now, once you have the dotted line, you want to make a table of values. And I'll put 0 in the middle. And then let me go backwards, and then let me go forwards. So I always put 0 here if it's just x. If the problem says if the exponent is like x plus a number or minus a number, we'll do something different. But based on the example you sent me, it looks like it's just going to be x. And if it is, just put a 0 there, there, there. Now, we need some y's. So for instance, take 0 and plug it in for x there. It'll be 4 to the power of 0 plus 3. So it'll literally say 4 to the power of 0 plus 3. Type that into a calculator, and it'll be the number 4. And that's why it goes there. Now try this again. Now take 1 and plug it in for x there. It'll be 4 to the 1 plus 3. Calculator if you want, you'll get 7. Plug in 2, you get 19. Plug in negative 1, and you'll get like 3.25. Plug in negative 2 in there, and you'll get some other number. And turn it into a decimal. Whatever it is, you're going to get decimals. You're going to get solid numbers. The point is, take all these numbers and plot them on this graph. For instance, how about this point here, 1, 7. So that's 1, 2, 3, 4, 5, 6, 7. That's right here. 0, 4. 0, 1, 2, 3, 4. That's right here. How about this one? Negative 1, 3.25. So negative 1, and then 1, 2, 3, and a little bit of change. How about this? 219. So what's 1, 2, and 19 is way up here on the top of my table. That's going to be like way up there. And this guy here for negative 2, I guarantee you for negative 2 for x, whatever you get for y, it's going to be 3 point a little bit of change. So you see the suggestion. The suggestion here is that these points should be connected like this. We can see here in green that it looks like this. And notice that this green curve, it doesn't cross the line. It just gets really, 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 really close to it. So now for the domain is going to be this. All real numbers. The domain has to do with the x values that we can safely use. Now for this exponent, I can plug in a number for x that's positive, negative, or 0. There's no restrictions, there's nothing dangerous about any number that you can plug in for x. Whatever you plug in for x, you're going to get something back for y. So for all of these problems here, the domain is going to automatically be all real numbers, but not necessarily the range. You see, the domain deals with the x's, the range deals with the y's. If I grab any one of these points here, they're all going to have something in common. All of the y coordinates, see all these points? All of these points have something in common, and that is this. Any point that you grab from here, I guarantee you one thing. The y coordinate, it's going to be bigger than 3. And you know why it's going to be bigger than 3? Because this entire graph is physically above the asymptote, in this case, 3. So for the range, you're going to say this. The y values, whatever the y coordinates are, y is going to be greater than 3. And it'll be less than infinity. So maybe you've seen this notation in class. If you have not seen that, you can just say this. Y is greater than 3. This range talks about the y's. And all of these y coordinates are going to be bigger than 3. The equation of the asymptote, here it is. Y equals 3. For all of these problems, the equation of the asymptote, it's always y equals the number that's in the back. So that takes care of this one. Let's try this one. Let's go a little faster this time. So here for the x's, 0, negative 1, negative 2, 1, 2. If I plug in 0, I'm going to get negative 1. If I plug in negative 1, I'm going to get 3. If I plug this in, I'm going to get something like 23. If I plug this in, I'm going to get like negative 1.8. You're going to get numbers, decimals, whatever. So you're going to get some number here. Let's plot these points. But before that, let's actually graph our asymptote. The asymptote here is always the back number. Whatever's in the back, that's the asymptote. Here it's negative 2. So go down to negative 2. And that's your dotted line. Okay. Now let's plot these points. So for instance, negative 1, 3. Negative 1, 1, 2, 3. And then 0, negative 1. 1, comma, negative 1.8. It's like right here. And negative 2, 23 is going to be way up here. And then 2 comma whatever you get, it's going to be something that's really close to the asymptote. So here, the points are suggesting that it look like this. You see that? It's going to get really close to the asymptote, but it's never going to quite get there. And the equation of the asymptote is always y equals the back number. Here, the back number is -2. Boom, that's your asymptote. The domain, as we just said, all real numbers. What about the range? What do all of these points have in common? All of these points have in common that the y coordinate is above -2, because this line is physically above this graph. It's physically above -2. So just say something like y is greater than -2. So you see how the range and the asymptote, they're connected. They almost always have the same number, if not always, and you just have to decide if it's greater than or less than. So let's do a couple more and then we're good. Let's see, for this problem here, I want to graph my asymptote, but darn it, there's no number in the back. You know how that's the asymptote? That's the asymptote. This has no number. So if it has no number, just put a +0. And that becomes your asymptote. So here, the asymptote is 0. And y equals 0 would be like this. It's going to be above the x-axis. It's sort of going to camouflage on top of the x-axis. Now let's pick some numbers. Right, this is usually the numbers you pick if it's just x. Now plug in all these numbers, plug in 0 and for x. Do this in a calculator. I mean, why do it in your head if you can use a calculator? So now let's plug in these points. So for instance, 1, -5 would be right here. And then 0, -1 would be right here. If you plug in -1, you're going to get -0.2. I'll just try that one in my head. And that'll be like right here. If you plug in -2, you're going to get something for y that's really close to 0. And here the suggestion is that the graph looks like this. See that? And let's see, the domain, all real numbers. This is the symbol that represents all real numbers. Now the range. What do all these points have in common? All of these y coordinates are below 0. So here the range would be all of the y's that live on these points, all of the y coordinates are negative. They are all less than 0. That would be a range. How about this one here? So there's no number in the back. So what I can do is I can put a +0, and that automatically becomes my asymptote, y equals 0. And the graph of that y equals 0 would be again above the x-axis, sort of hidden by it. Now let's pick some numbers. Plug in -2, you're going to get 9. Plug in -1 there on a calculator, you're going to get 3. This will give you 1. This will give you 1/3. And this will give you 1/9. And if we plot these points, here in red, I suppose, we get -1, 3. And then we get 0, 1. 1, 1/3. 2, 1/9. And -2, 9 would be like way up here. So here the suggestion is that it looks like this. And the range is all real numbers. Now what about the y's? The range, the domain is all real numbers. The domain is all real numbers. What about the range? All these y coordinates are what? All of these y coordinates are positive. They're all above 0. So the range would be y is greater than 0. So as a general rule of thumb, if the leading coefficient, if that number is positive, your graph is going to open above the horizontal asymptote. You see that's positive? It opened above. It was above. If the leading term is negative, then your picture will be underneath that horizontal asymptote. You see here it was above because that was positive. So there's more to say, but give that a go and let me know if you have any more questions.